So far we have seen singly linked list, which means that we will be having only one link in a node which stores the address of next node. The main drawback of such a structure is that if we want the details of just previous node to that of the current node, we may have to use a different pointing variable for storing the details of previous node, because we can move only in the forward direction from current node to the next node. Reverse movement is not allowed or not possible. A variation to this was the use of circular linked list, where we use the address of head node or the first node at the address part of the last node, so that after reaching the last node we can again go back to the first node. So when the list is very large, this process is very time consuming, is it not? If you are moving from, if you want to move to some 500 or 600 nodes, then we have to move all through the list up to the end mark and come back to the front and move close to the current node just to reach the previous node. It's a very time consuming activity. So we have a new structure which is used to move in the forward and backward direction simultaneously. We can move forward or we can move backward. So we are using a new structure where we store the addresses of the nearby nodes, which is the previous node and the next node, by including one more address in the node. So the node looks like this. We have the address of previous node, we have the information field, and we have the address of next node. So in the same node we are having two addresses, therefore it is called as doubly linked list, because it is having two links, link to the previous node as well as the link to the next node. So the structure will be like this. We are using the structure tag as node. The first member is PREV. These are the member names: PREV, info, and next. So here, since this PREV and next are pointing to a node of this type, nodes of this type, these addresses are called, or links are called, self-referential links, because it is pointing to the node of the same type. PREV is also pointing to the node structure, so as next. This is also pointing to the node structure. So there are two self-referential structures in a doubly linked list. The main advantage of using such a structure is that we can move in the forward direction as well as in the backward direction. So the structure like this, structure will be like this: struct node, a pointing variable which can store the address of the previous node. Then the information part, it can be integer or float, any data type, can be multiple in number also. For simplicity, we are using a single value which is termed as info, and it is storing an integer value. We can have different types of values here. We are storing only int, for example, and this one is the second link, which will be storing the address of the next node. So struct node next. This is also a self-referential pointer. So with such a structure we can have this type of node, and this can be, such nodes can be linked together to form a doubly linked list, which looks like this. So this is the first node, second node, there are 4 nodes in it. As in the previous case, that is single linked list, the last node always point to an invalid address which is null. For all other nodes, internal nodes, we will be having two links, one to the next node and the other to the previous node. For all the nodes, we will be having two links, one to the right and one to the left. So the first node will always point to null as the previous node because there is no node to the left of this first node. So the previous link in the first node will be always null, and the next link of the last node will always be null. As usual, we will be having a start or head to store the address of the whole list. The address of the first node will be stored in head. So on reaching this node, we can move in this direction, and through this link we can move in the backward direction. The rest of the things remain same as in the case of single linked list. We can add or remove elements. While adding, it can be done at the front of the list or at the back of the list or in the middle of the list. The same actions are possible in the case of deletion also. We can remove from front, remove from back, and remove from the middle. All operations are possible here. Traversals are possible in forward direction as well as in the backward direction. In the forward direction, we will be using next link, and in the backward direction, we will be using the previous link. Hope it is clear to you. While inserting and during deletion also, we have to take care of double links. So far we have been using only single links. So when we are using doubly linked list, we have to take care of double links while addition and deletion of nodes in the list.